So both of these, I think we've discussed a lot that both of these are A and D are neutral because they are conjugate bases of strong acids. Now, we also discussed that you can add the water or not, but I have to say, I'm beginning to think, I never used to, but I actually am beginning to think it's easier to add the water, especially with bases. Definitely easier to add the water with the bases. Because when you add the water, you end up with the OH minus plus the conjugate acid, so it's definitely easier to add the water. And I'm beginning to think with acids it might be easier also. Okay, so 95, any questions? 99 is the same thing, only acidic. All right, so 99C, I was looking at that and I was saying that's not right. That's the one we want to talk about. So let's do that. This is acidic. All right. This one here comes out to be acidic. Here's why. Weirdly, when you did this, if this is cobalt, if you did this out on the little chart, right, you would get to this, the little chart that we did yesterday, you would get this to this, and you would get to that box, and you would say, is it an acid? No, it's not, because like sodium, it does not have a proton to give, right? But here's the thing. Lewis acids, this is a Lewis acid, which has, Lewis acids are defined as electron acceptors because they have this high number of protons here. And so they accept electrons. And as a Lewis acid, and when you think about it, it's going to take negative ions, right? It's going to take like Cl minus, right? It's going to take a Cl minus, so it's going to take electrons. So it's called an electron acceptor because it has these protons. So as a Lewis acid, it would become acidic. The weird part about this is that it would look, they look very strange because they add on 3 of the whatever it is that's hanging out. It's very, 6 of whatever it is that's hanging out. So we'll talk about it later, but for right now, the definition of how do you know if it's going to be one of these, this is how you know. Small, highly charged, metallic ions. So what would they be? They would be +3, and they would be transition metals or aluminum. Highly charged, metallic. So it would be like iron 3, cobalt 3, aluminum +3, magnesium 4, small, not silver 1. Nope, that wouldn't work, right? Because that's silver, it's larger, and it's +1. So it would be things in that first row of transition metals and aluminum, and they would have a +3 charge. Highly charged +3 metals, okay? They would cause it to be acidic. So when you look, continuing this conversation, then going back to 99, 101A, the compound was iron 3 chloride. So when you got there, you said yes to iron +3 because it's a highly charged small metallic ion. It is a Lewis acid. We are not really responsible for a whole lot about Lewis acids, but this is one thing that my understanding is, as I said, you're not really responsible to know about it, but if it comes up, it sure would be nice to get that 1 point. So nobody can say for sure whether it will come up, but if it does, it would be nice to just kind of like know it, right? And so when we did this chart, the answer is this one, which you might have put down as being neutral, actually comes up as being acidic because the iron 3 is a small positive, highly positive charge. If it were Fe2, probably not, but they wouldn't give it to you because they're trying to know if you know about the small, highly charged metallic ions. They wouldn't give you Fe2 and ask you that because that would be on the edge, right? All right, and so it's a Lewis acid, which is an electron acceptor. It is a small, highly charged metal ion, okay? All right, so going back up to 99. Any questions? Okay, and then 101A, you can look at the boxes, so you can see that these two are no. Chloride is not an acid. Iron is not a base, but it is acidic, and it is a base for the chloride, but it's too weak. And you need to write that chloride is too weak to affect the pH. Okay? Questions? All right, let's go on to the next one. So 101B, it is neutral and a base, so HF is basic. The reason it's basic is because, not HF, sorry, sodium, NaF, sorry, NaF. Because HF is a weak acid. Everybody okay? Good. The charts worked out all right? Yeah? All right. So the next one is calcium bromide. So again, bromide, calcium is no. It's a large, so those metallic ions would not be alkali metals or alkaline earth metals. They are only transition metals. First line, small transition metals with high charges. And aluminum. Aluminum will do it too. Okay? So calcium, no, neutral. Bromide, no, and yes, but strong acid, so neutral. So this would be neutral. Next, ammonium bromide. Yes, weak base of ammonia, right? Conjugate acid of ammonia, which is a weak base. And no, because hydrogen is positive. So that makes it acidic. Bromide is a no, and then yes, but it's a conjugate acid of a conjugate base of a strong acid. So acidic. Questions? No? All right. Okay. Next one. So this one turned out to be an acid and a base. Here's the little chart. Questions on the chart? Let's start there. Then, now you have to figure out whether it's going to be acidic or basic. So to do that, I need to find the Ka of this compound. So I took the Kb of its acid, because of its base, because it's the conjugate acid of this base. So in the book, in the yeah, well, it was either, There's a big supplement, but also in the chapter beforehand, there's a couple. These aren't used very often, and I didn't want to complicate the list. I really want the list to be for you to understand strong and weak, because they're not expecting you to memorize these. You know what I mean? So they're going to give these to you on the test. So really, I just want you to know strong and weak. So I didn't want to put it all there because that's just really overwhelming to have all those numbers and everything. So, all right, so KW divided by the KB gives you the KA, and then the KW divided by the KA gives you the KB. So I like to write out that since this is an acid, since this is acting as an acid, I am looking for the Ka of this. And so I am going to divide the KW by the KB of what it is not, if that makes sense. Because it's kind of confusing whether I'm looking for the Ka or the Kb or whether it's acting as an acid or not. So I look at my chart and I say, it is acting as an acid, so I need the Ka, which means I'm going to divide it by the Kb of the conjugate, whatever, it is the conjugate acid of this base. That's what I need the Kb of, because it is acting as an acid according to my chart. So over here, it is acting as a base. I need the Ka of the acid that it is the conjugate base of. Okay? Now, whichever is larger, the acid or the base, that is going to dictate whether the solution is acidic or basic. Now, the last one was the same thing. I went through the box. I didn't do the CL because I think we've gotten to the point where we know that it's neutral, right? But with the NH4, I did because I wanted to exercise it again, exercise that pattern, exercise that brain and that skill, right? And I came up with acidic. Then I found, what I'm looking for is the pH. So I found my Ka, right? And then I did my without an ice table, right? And I found my H plus and I found my pH. Questions? Now, thoughts here are, you want to do an ice table here because they need to see your work. Don't just chuck it out there like I did, all right? Don't assume that they know that you know. And you want to write this out. You have the time, write it out. Tell them that you know, because you do. In many of these situations, you're going to know. I believe that you are. I'm going through multiple choice questions now with this kid that I'm tutoring. We know everything. Out of 50 questions, we absolutely know 42 of them. There's no two ways about it. So it's a matter of reviewing and remembering everything. But we totally have learned 42 solidly, on this test that I'm looking at. It's just a matter of reviewing. Maybe 10 of them you'd have to sit and kind of like wiggle your way through. 15 of them, wiggle your way through, but not more than 15. Absolutely not more than 15. So it's a matter of making sure that everything's written out and that you clearly tell them justify versus explain, justify versus explain. Explaining is using concepts, justifying is using numbers. Okay? So that's what the practice is about. Okay, are there any other questions? Oh, sorry, BC. Here we go. Woo. So in this one, right, I know that the sodium is neutral. Again, I would have set up a chart here. If it was a single problem that I was doing, I would set up a chart. Then I find my KB, right? I take the KA, I find my KB, I set my KB up, I would set up an ICE table. I find my OH minus, because remember, we're working in a base now, right? So we're working in a base. So X is now your OH minus. When you do your ICE table would now be CH, C2H3, O2 minus plus water yields H, C2H3, O2 plus OH minus. So here are the three things on your ICE table. Reactant, product, reactant. Product. See that? Those are your three things. You're not including the water because it's a liquid. Questions? Okay. So I'm including these three things, right? So then, when I do this, the X that I come up with is both this acid and the OH minus. Because I wanted the pH, I'm only looking at the OH minus. I get my concentration of OH minus, and then I subtract it from my pH. Okay? Okay, now, with the sodium chloride, the sodium is neutral, the Cl minus is neutral, my pH is going to be 7. Again, I would have done a box, but I think we've kind of beat this dog. We beat this horse. But when you have to show them that you know, you're going to set it up and you're going to go through it when it comes up as neutral. All right? Okay. Okay, so that's the end of the homework video.